observability. No surprise there, but this is from a very, very basic standpoint. So if you have no clue what's observability, if you're coming from a non-production code-based background, then this is something you might enjoy and have a lot to learn from. So my entire agenda is in the form of questions we'll be answering today. So we'll start with a quick hello to me. Then we'll see what's observability for folks outside engineering. When I say outside engineering, I mean anyone who has zero experience with production code base or has not worked with DevOps. Then there's for engineers, basically people who have a little bit of idea of DevOps, who've worked on a little bit of production code base, but haven't really worked on testing and incident response. Then we have a quick overview of how we make a system observable. Then we talk about streaming databases, also one of my favorite databases that I've come across recently. And then we get into the block diagram of the project that I created to understand observability better. Alright folks, let's start with the answers. So hi folks, I'm Ritvi. I am a maker. I love learning new things and then talking about them. I'm currently freelancing from a DevRel standpoint and a firmware engineer standpoint. I'm a coach at Major League Hacking, and I love that job because I get to do all the things I love, from mentoring students to teaching to coming up with quirky project ideas all at once. So as you all might notice, the theme for this presentation is quite unusual, but then it is summer and I decided that we are talking about observation and correlation, so might as well come up with a nice fruity summary recipes based presentation theme to kind of go with our topics. So let's get started with what is observability. Right. So before we go on here, if you're actually very new to this world, to this word, I want you all to take a second, pause the video right here for 15 seconds and just think of the first thing that comes to your head when you think of observability. This is something called the intuition exercise that I do for most of the topics that I especially take virtual sessions on, because it's hard for me to gauge whether or not you're understanding where you're coming from. So if you do this yourself, it's much easier for you to kind of untangle threads later when a lot more terms are thrown at you. Right, so let's take just 10 seconds right here, and if you all are watching this live and it's going on, type in the first word that comes to your head when you hear the word observability. Alright, I'm going to move on. So I hope you typed in the first word that came to your head. Trust me, this will really help you correlate with everything that I talk about today much easily and in a more holistic way. And then it is about observation. So what better, way to get started. Alright, so talking about observability for everyone. Well, let's start with one thing that we would not be very intuitive about when it comes to observability, right? We would never consider observation a measurable quantity, but that's the first thing that we need to know about observability, that it is a super measurable quantity. And if it doesn't make sense, then remember when you're trying to make a system so measurable that it becomes easy to observe. This is the best I can put it, so it makes more sense in terms of measuring observability. It is more than just a status. On those startup websites, you go down and there's a green, all okay, all systems working, status okay buttons. Observability is way more than that. There is a system that's keeping in check and reporting a status, but that's not what observability is about, right? It is a very layered process. We learn about how there are, lots of points that go into making a software or an application observable. A great example to go about imagining observability is fast fashion. Now, the comparison might seem absurd, but I promise you it will make sense when I explain it. So I don't know if how many of y'all know how fast fashion works, but the basic working of fast fashion is that they're keeping a tab on a lot of things. For example, the trends, the current fashion shows, the current hypes, not just these, but also social media trends to finally push out their new products. Then they also keep a tab on their customers. What clothes are they viewing, regardless of the trend? And then there's a lot of data correlation that's happening. That's a great example for observability. They're not just keeping in tab a particular cycle, they're not just keeping in tab a status per se when it comes to a product. They are constantly observing customer versus trend versus social media versus influencers versus a number of factors. For example, the lead time to get a cloth, to get it stitched, etc., the colors available, whether a celebrity picked up on some trend and is following it. There are so many layers to it that fast fashion is following and then pushing out clothes with almost 3 weeks lead time. And that's while not very environmental friendly, it's a great example of how observability really works. So if you read more about this, you'll realize how this analogy makes perfect sense. And with those beautiful raspberries in mind, let's move on to the origin story of observability. So why has observability become such a trendy word in engineering? Why is everyone talking about observability? Why are there so many products overnight doing so well? Helping you all achieve observability in your systems. So let's go back to the origin of the word observability. So the term observability was coined by engineer Rudolf in 1960. Right, it has grown to mean so many different things in different communities, but it has its own meaning and definition in the modern software systems. Right, in the 1960 paper, he introduced a characterization he called observability to describe the mathematical control systems. So, in control theory, we usually have a measure of how well the internal states of a system are working or are inferred in terms of their knowledge from its external outputs, and this ratio is called observability, or this measure is called observability. So when you study observability and controllability, they're actually mathematical duals. So these come along with sensors, linear algebra equations, and like tons of formal methods. So the traditional definition of observability is the realm of mechanical engineers and people who have a heart for physical systems with a specific end state in mind. If you're interested in knowing more, there are some really nice blogs available on correlating observability and mechanical systems versus modern software systems. But yeah, that's how that's the origin of observability as a word. But let's look into the adapting concept of observability to software, right? So when we're adapting this definition to software, we must also layer additional considerations that are specific to the software engineering domain. For example, for a software to have observability, there needs to be the following for you to even consider having observability in your. So you need to be able to understand the inner workings of your application. You need to know the state your application may have gotten itself into, or that it's reaching states that you can't predict. You need to have a system state solely by observing and interrogating with external tools. And you should be able to understand the internal state without shipping any new custom code to handle it. Because it's again basically reiterating the above point that it's reaching places you can't predict, right? All right. So basically, to have a system to be observable, it's the same thing over and over again that we iterate that it has to be uh, unpredictable is what we're trying to establish for a system to be observable. Now, why do we want a system to be observable? Why not just observe it anyhow? Well, for starters, you don't always need observability if it is, for example, a monolithic application or an application that does not or is not meant to support a lot of users. We'll get into that in a little more detail in a bit. All right, so let's talk about why we need observability, and let's talk about a couple of other questions that come into picture when we say we want to make a system observable. All right, so let's start by asking the question, why are existing methods weren't enough, right? Why did people have to go out of their way, come up with a completely new, very layered process to monitor, basically, right? Well, first, it is not an equivalent to monitoring. Observability is way more than just monitoring. It's about the software reaching unpredictable places, but you being able to be ready with an incident response before it reaches that unpredictable place by constantly, keeping a tab on different factors that can even remotely affect your system, and also making sure that when you're keeping a tab on these things, you're constantly also using different tools to correlate all the data that you're collecting, and making sure that you know what is happening, when is happening, because of what is happening, right? And I know it sounds okay, so we are basically monitoring, but it is, I promise you, way more than that. Let's reiterate back to the definition of observability, but this time in a slightly more technical manner. Alright, so these are the terms that I'll be using a lot, right? Logs, errors, traces, metrics, cardinality, and dimensions. Now, these are very commonly used terms in the world of observability, so it's nice if you all get acquainted with them, individually. Alright, so let's start looking into sentences that we can form using these words. So let's start with the three pillars of observability. Alright, so your first three words on the left, that is log, errors, and traces, are your three pillars of observability. Why, how, we look into that in a tad bit. Okay, a single number with tags optionally appended for grouping and searching those numbers. This is basically what we call a metric, right? So monitoring depends a lot on metric. A metric is a single number with tags optionally appended for grouping and searching those numbers. So basically what we're saying is a metric is already assuming that we only want correlation in this particular way and then getting numbers, right? Next, let's go on to the next sentence. Every application has an inherent amount of reducible complexity. The only question is, who will have to deal with it? The user, the application developer, or the platform developer? Well, this is the question of why do we need observability, right? So, who is dealing with the problem of this complexity that is scaling with every new application that comes into the market, right? So, that is where observability steps in. So when you have a application with irreducible complexity, you bring in observability, which has these three main pillars, which is logs, errors, and traces. And then we use our two more terms, which is cardinality and dimensions. So comparing high dimensionality and high cardinality data becomes a critical component of being able to discover otherwise hidden issues buried in complex system architectures. Alright, so let's talk a little more about what do you mean by cardinality and what do you mean by dimensions. Well, cardinality refers to specifically data which is very rare. So, what do you mean by very rare? Which means it is a very low occurring data. So, if you, let's say, have a log with 100 events happening, and there's one data that happens every one in thousandth event, right? That is your cardinal number, which this basically means it is happening. It's a highly rare data type or occurring data, right? Then there's called dimensions. Dimension is basically a key value, basically a data set or a data pair which you define based on the permutations you create with your cardinal data. So how does this help? Let's look at the sentence again, right? Comparing high dimensionality and high cardinality data becomes a critical component. So high cardinality automatically reduces your entire available data to a very small number of data, because you know that the cardinality, if it's a high cardinality data, that means it's already occurring very less, right? Then comes dimension. So dimension is basically how many permutations can you make with your data available, and using a high cardinality key gives you, while less dimensions, it'll give you very unique dimensions. And using creating these permutations and comparing them, it becomes a critical component in being able to discover otherwise hidden issues. So you're basically taking a lot of data, measuring it, correlating it in a way that only rare events are being correlated with each other, and then you're trying to see how and when the system will go into an unpredictable state, predicting it beforehand, and then being able to keep a tab on it. Now, this might seem obvious after listening to the explanation, but it took me quite a few blog posts and videos to understand this basic concept, right? It is not, the world seems fairly easy. Like, okay, we're trying to observe something that might not happen, or might not happen because we have predicted it. But this basic concept helps you apply it in your own applications, and make your system observable without making it highly complicated. Even though I understand that you do not want to apply it to applications that aren't highly complicated, but this entire exercise is to, understand the world of observability better. Alright, folks, now that we understand basically what observability is, let's move on to some simple facts. And then we will look into some tools for observability. Alright, this is another great analogy that I love giving. Students monitor, but teachers observe. So, remember in school, your teacher used to allocate someone as his class monitor, and they would never be the teacher, right? They're just monitoring for a certain period, and they have their biases, etc. Right? But the teacher, even when they weren't actively monitoring or trying to keep the class in control, they were constantly observing. So that's something similar to the difference between monitoring and observing. Alright, so let's look into some facts. So the more highly dimensional your data is, the more likely you will be able to find hidden or elusive patterns in application behavior. In modern systems where the permutations of failures that occur are effectively limitless, capturing only a few basic dimensions in our telemetry data is insufficient. Obviously, right? Because the whole point of us bringing in observability was because we weren't able to predict the states that the system was reaching in time for us to have incident response in a way that is helpful to the application, right? So what do you go about, what is the next action plan of action for you all to make sure that your application is constantly observed in the right way? Well, we want to gather incredibly rich detail about everything that's happening, right? Especially at the intersection of users, code, and your user systems. Right? High dimensionality data provides greater context about how those intersections unfold. Remember, because our high dimensional data is also something that is coming from cardinality, right? And when you're doing that, you're basically making these deep but fairly unique assumptions, and not just assumptions, but predictions that are you are ready to handle way before they can happen. Alright, so how do you make a system observable? And then obviously, if you're making it observable, actually observe it. Uh, okay, so making a system observable, there are four steps to it. First is instrumentation, which is basically collecting all the important data that you have, right? Then there is data correlation. Again, basically creating dimensions and using cardinal data to create some very unique data correlations. And then there's obviously incident response, which is basically being ready for an unpredictable state which has been predicted by your observability system. And then the you know, new thing is the AI ops, which is basically using a little bit of AI to make your observable system way smarter. We will talk a little more about instrumentation. So, why do we want instrumentation? Well, you can't always have the application send certain data, especially because you know that you have a lot of resource consumption while the application is running. So you use specific tools to, specially instrument all the data, collect it, and then send it to your, favorite place of data correlation. Then you do the data correlation there. Your incident response happens based on what you're trying to predict, what you're not trying to predict, based on your application type, if it's front end, if it's back end, etc., etc. And then there is AIOps, right? Which I haven't looked a lot into, but there are some pretty cool applications out there helping you do that. All right, so we spoke about, you know, there being specific tools to help you all send your data to the place of your choice to correlate data. Well, my favorite place has been a streaming database to correlate data and to create views that help me do incident response rather, efficiently. So, the best way to correlate a lot of data and to, be able to take out your correlated data in a separate location altogether is a streaming database, right? Especially right now, when I'm trying to understand and basically get the hold of fundamentals, it makes more sense to use a streaming database, which basically has the following working, right? I love open source tech, and I recently came across this really cool streaming database which lets me run it locally and on the cloud, and lets me create something called materialized views. We'll look into that in just a second. But this is basically how a streaming database works. So Rising Wave is the name of the streaming database that I have been playing with like crazy, and I love being able to create materialized views with. It basically has event streams. It ingests it, then it creates something called the materialized view, and then it either triggers actions or event stream again based on your application. So before we dive into the block diagram of what I created, let's look a little bit more into how Rising Wave works. So this is the Rising Wave docs, and like you can tell, I absolutely love their docs as well. It's very efficiently organized in terms of what I need, and I especially love the tiny GIFs that they've created all over the place. But basically, this is the key part of what we are trying to apply. So Rising Wave can run in both local and their cloud that they've recently released in the beta trial format. I usually prefer the local version. So how does Rising Wave support real-time analytics? Well, Rising Wave supports real-time analytics by ingesting and transforming data in real time with a variety of data sources, and then it maintains fresh results in the storage. So what it's basically doing is it's creating a sort of a filter, right? So when you're sending it tons of data, it you're also creating a filter. You're saying, okay, uh, that's okay. I have a lot of data, but now in this new table, I want you to keep this correlated data for me, right? And because it's a streaming database, it's easier to kind of play with its relational part of the entire query. So there are some really cool examples here as well, which they have done. So let's have a look at this. So clickstream analysis is something what I compare to front end observability. So this is a great example to deploy if you all ever want to get started with streaming databases or with databases that help you create a nice filtered view of your data. Again, the streaming database has a very wide array of usage. It is not specifically for observability, but it does do that task very well. Now you can see that it has the documentation also has a lot of comparisons with its current from the inspiration rather, where it builds upon. Again, it's completely open source, and you all can also go ahead and contribute to the documentations. And they have an active Slack as well if you all want help from the community real time. They have a very detailed list of sources you all can connect it with, and a lot of syncs that you all can connect it with as well. You all can also go ahead and create your own visualizations depending on what you want to visualize it with, which is also what makes it my favorite tool for basically any observability test that I've been conducting in the past few weeks. So what did I do to make my streaming database an observable tool or an observability tool? This is the block diagram that I followed. Now, to actually demo the entire thing would be another 40-minute session altogether. So I'll just take you through the block diagram, and then maybe I'll just write a blog post in a bit to, show how I did it and show you how it works. Right? So first I have a simple algorithm generating art, which is basically, a tiny spiral. I used a React front end, and I'll also show you one of my favorite tutorials, which got me started on observing front end, right? You want instrumenting, so any data, right? You want to instrument. Remember, you're not trying to make your system observable, you're just trying to learn how observability works, right? So you want to instrument some form of data, any data works, right? And then you want to send and analyze the data. So again, this is where the streaming database comes in. So you have first algorithm. Over here you have an instrument that is basically sending data to your database. The database that I used was again Rising Wave, the streaming database. It is creating materialized views. So, like we said, materialized view is basically the filter, which is basically what observability does, right? It creates correlation and then gives you states that cannot be predicted. And from here, ideally, you want to send it to a observability stack again, which is basically something that helps you do incident response. But again, this is us just trying to understand observability. So for incident response, what we've done is basically we've just uh, added another parameter in the generative art and fed the materialized view or the new correlated data back into the art. And for the just for the sake of understanding how correlation helps create a lot of difference, you generate the new parameters separately as well. Now over here, you can keep for the instrumenting some or any data, you can keep making it as complicated as you like, right? So for example, I started off with just observing a click on the screen, and then I started feeding the entire parameter into the database, and so on and so forth. You can just keep adding on to it and creating new just layers of data and sending it to the database, and then making it more complicated to understand how it actually makes more sense. It starts making more sense when you start making it more complicated. Alright, folks, that's it from me. I hope you all had a lot of fun learning about observability. And yeah, if you all want to reach out to me, you all can reach any of these contacts to reach out to me. I'm again learning a lot about observability on the go. So if you all want to come learn with me, hit me up. And if you all have any feedback regarding the talk as well, do let me know. A huge thanks and a shout out to Conf42 for accepting this talk. This is a very, very noob oriented talk. I had a lot of fun learning about and presenting it in such a way. And I hope you all had fun as well. If you all did the intuitive exercise, now is a good time to kind of correlate and see how much you understood or what you intuitively understood made so much sense. And once you do, it's going to be very difficult for you all to not remember it the way in a way that you just correlate everything that comes your way with observability. All right, folks, I shall see you hopefully at another conference soon.